In learning target 7, we're finding infinite limits, all right? And an infinite limit occurs when the function increases or decreases without bound as x approaches a certain value, all right? So in previous sections, we might have said the limit does not exist, and it still does not exist, but now we can specifically say if it's approaching infinity, we'll say the limit is infinity, all right? Or if it's approaching negative infinity, the limit is negative infinity. So here's an example, all right? This is already worked out for us. It says find each limit, and we have the limit as x approaches 1 from the left of this function, and limit as x approaches right, the one from the right of this function. And if you put 1 into the denominator, you're going to get 0. We can't divide by 0. We also know that we can't simplify this at all. So we have two non-removable discontinuities, and we have two vertical asymptotes. Okay? So we can't tell what's happening unless we look at a graph. So you would need to type this function into your calculator. All right? Make sure when you type it in, use parentheses. But here's the function. All right? Here's your vertical asymptote at x equals 1. Okay? So if we're looking at the limit as x approaches 1 from the left, well, from the left, that means we're in this direction, so we're following this function, and it's approaching infinity. So limit equals infinity. It keeps going up and up and up and up, and it's never going to stop, so we say it's approaching infinity. For the limit as x approaches 1 from the right, that means we're in this direction, so we follow this value, this part of the graph. It's approaching negative infinity, because it's going to go down, 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 and never stop. So it's approaching negative infinity. You would have to use a graph to look at that. So on a lot of your homework tonight, all you're doing is you're looking at a graph, and you're trying to decide, okay, is there a limit that goes to infinity or negative infinity? Okay, again, this would only happen around vertical asymptotes. So with that being said, you should always, 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 always try direct substitution first, or try to simplify the function first. Okay, that way you can see where those vertical asymptotes are, so you know what you're looking for. All right. So for example, here's this limit. It says the limit as x approaches 1 for x squared minus x divided by the quantity x squared plus 1 times the quantity x minus 1. So if I try direct substitution, I'm going to put 1 in, and I'm going to get 1 minus 1. That's going to be 0. And I'm going to multiply all this, and we're going to get 0 in the denominator. That's a problem. Okay? But I think that I can simplify it. So if I can simplify the function, then you should, and then try direct substitution again. All right? If you can simplify the function and get rid of the removable discontinuity, then you don't have vertical asymptotes because you don't have non-removable discontinuities. All right? So if you're looking at this function, x squared minus x can be factored. There's an x in each term. So I've got x times x minus 1. In the denominator, I have x squared plus 1 and x minus 1. So I can cancel out the x minus 1 factors. And I am left with x over x squared plus 1. That means that when x equaled 1, we had a removable discontinuity. If we had a removable discontinuity, that was not a vertical asymptote. If it's not a vertical asymptote, then we probably don't have an infinity limit that's approaching infinity or negative infinity. All right, we just had probably a gap or a hole or something going on with the graph, not an actual asymptote. So now I'm looking at the limit as x approaches 1 of this function. So let's try direct substitution now. Well, so now I have 1 over 1 squared plus 1. 1 squared is just 1, so I have 1 over 1 plus 1, which is 2. So the limit as x approaches 1 is 1/2. All right? So that's all there is to this learning target. You're still finding limit. But in this case, if you cannot simplify anything, if you couldn't on this first example, look at a graph, look what's happening, and find the actual limits. Is it infinity or negative infinity? But don't forget that you can still use algebra and you can still find limits. All right, so not every single homework problem is going to say infinity or negative infinity as an answer. Again, try direct substitution first. If that doesn't work, try to simplify using algebra and then directly substitute. And if that doesn't work, then you should look at a graph on your graphing calculator and find the limit that it's asking for. Right? It's probably happening around some vertical asymptote because it's a non-removable discontinuity. That's why you couldn't do anything else to fix it. That's all learning target 7. Infinity and negative infinity for an actual value. All right? So you should look and see what's happening with each function.